Good morning, dear students. So welcome to another session of Introduction to Data Structures and Algorithms. So in previous session, we started our discussion with respect to linked list. So in which we went through what is an array, so that we could compare this with how it is different from the linked list. So then we started a discussion pertaining to linked list, and we saw what are the terminologies which are used in this linked list, like what is the first pointer for, what is the last pointer for, what is the info field, what is the next field. So these all aspects we had discussed. So then we saw the advantages and disadvantages, and we looked into one of the implementation pertaining to linked list. So this is what we had observed in the previous case. So we had discussed even the insert and delete operations in the linked list aspects. Let us discuss the search operation pertaining to the linked list. So when we want to search an element in a linked list, so what is the logic we need to look out for, or what are the steps we need to perform? So first of all, what we have to do is we have to traverse through the entire linked list. And when we are traversing, we start off with the first node of the linked list. And if the search is successful, that is whatever element I'm searching in the linked list, if it is present, then I return the location of the element, or else I'll be not returning anything and I'll be specifying that the search was unsuccessful. So that is indicating that the list or the element what we are searching in the linked list is not present. So here, when we are searching the element in a linked list, we have to start with the first element and traverse through the entire linked list. And if we identify that the element is present in the linked list, we return the location, or else we indicate that the search was unsuccessful. So this is what we do in case of the linked list, search operation in the linked list. So now let us look at an algorithm on how we look for a specific element in a linked list. So in this case, again, the name of the algorithm is specified as search, and the parameter or the element what you want to search will be present in the variable, say, value. So I need to check out whether this value is present in the linked list. So I start off with this algorithm. So what is the first thing I check? I check whether first is equal to null. So what is this indicating? So this is indicating that if this field is null, then actually there are no elements present in the linked list. So that is what we are checking out here. So if first is equal to null, then I go to step 3. So what is performed in step 3? We specify that search is unsuccessful. So element is not present. So indirectly I got to know that if there are no elements, there will be no values which are present. So therefore search will be unsuccessful, or the element is not present in the linked list. So therefore I stop my search over here. Now, if this is not the case, that is, if at least one element is there, so then what would happen? This condition would fail. So in that case, first would not be equal to null. So if this condition fails, then I need to go to step 4. So what is performed in step 4? In step 4, what you're doing is, so since you got to know that at least there is one element, in the linked list. So then what we do is we initialize a pointer parameter to the first pointer. That is, we initialize the pointer. We say take another pointer, and what we do is we initialize it with the pointer value which points to the first node. And then I start off with the search operation. So here I initialize ptr is equal to first. So now when I do this, what I have to do is I have to traverse through each of the elements and keep on checking till either I get the element or I reach the last pointer. That is, so I traverse the node 1, node 2, and if I'm not able to find the element before this n minus 1 nodes, then I traverse to the last element, and here I check. Even if I don't get, then I try to see whether I have reached the end of the linked list by checking with the last pointer. So here what we perform is we keep on searching for the element. We keep on searching for the element, that is repeat steps 6 to 8. That is, you are searching for the element until what? You check it until the pointer is not equal to last. So that is, you haven't reached the end of the linked list. So you perform the search operation till you reach the last condition. So now let us see what is present in step 6, 7, and 8. So when we come to step 6, what you're checking is you're checking whether the element present which is associated with the node, that is, say initially I have pointed it to PTR. So if I want to know what is the field, what is the element which is present at this location, it is given by PTR info. So remember when we are using say structure, now we have two ways of accessing the members. That is, if I just specify over here. So here you can see, so we have structure node. So this is a structure which is having two members. Now, if I want to access these two members, right, I can do it in two ways. One by using the dot operator, and one by using the arrow operator. So these are the two operators which we utilize to access the members of the structure. So dot operator is used when you are declaring a variable of the type struct node. Suppose if I write struct node and I write n1. So here n1 is a data type which is of struct node data type. So if I want to access say info in that, I'll write n1 dot info. I specify it in that way. Now, if I have a pointer of the type struct node, suppose if it was instead of n1, it was star n1. So this n1 is a pointer which points to the data type of struct node. So if I make use of pointer, in that case, if I have to access the members, I make use of this arrow operator. So arrow operator is used when you declare a pointer and try to use the pointer to access the member, and dot operator is used when you declare a variable and use that variable to access the member. So that's why you see arrows being utilized at some places. Okay. So here what we did, we tried to search, repeat the steps of the search till you reach the last element. So in the step 6, if we just observe, what we are doing is we are seeing what is the element which is present at the location which is pointed by pointer. So if this element is equal to value, then your search is successful. So then your search is successful. So what you do is if this condition is true, that is you have identified the element, then you go to step 7. So in step 7, what you're doing is you are returning that search was successful and you are returning the address of where the value or the element is present, and you're stopping at this point. Suppose if the value is not present at this address, so we need to update the address now. So suppose this condition fails off. So then we go to step 8. So in step 8, what we do is we go to the next node. So if I come over here, so what is the next node? Next node is given by this field, that is pointed by the pointer, using the pointer, I access this, I get to know what is the address. So I use this address and go to the next node. Then I check the info field. If the value is the same which I'm trying to search, then I stop the search, or else I use the next field and go to the next node. So this is how I keep on moving. So here we go to step 8. And here what we are doing is we are again initializing PTR to PTR next. So what is this doing? This is helping the pointer to move to the next node. So this is what is happening in this case. So now what you're doing is 6, 7, 8, you are repeating until you reach the last node. So once you reach the last node and you haven't searched the element, you perform these steps and you haven't identified. Suppose if you have reached the last node, so in that case, 6, 7, 8 will not be executed. So here now what happens is, if this condition is failing means we have PTR initialized to the last pointer value, that is address of the last. So here what we do is we have to check the last element. Since in 6, 7, 8, what we do is we search from 1 to n minus 1 nodes. So when we reach the nth node, we come out of this loop. So and last info value also has to be checked. So what we do is last info field is checked whether it is equal to value. So here also, if this condition at least gets satisfied, then we get to know that the search is successful. So in that case, we return that search is successful and we return the address and stop the search. But even if this fails off, so in all these steps, the value was not present. So if that is not present, you have reached the last element and you checked out here. Here also the condition is failing. So in that case, what we do is we go to step 11. So in step 11, what we are doing is we searched all the n elements or the n nodes, and we got to know that the element is not present. So in that case, we specify that the search was unsuccessful and we stop the process of searching. So this is what is happening in case of search operation. Now, in case of print operation, what we have to do is we have to traverse the entire elements of the linked list and start printing the elements which are present in the linked list. So again, in this case, what we are doing is we are traversing basically. But at the same time, as and when we get the elements, we print them. So in order to access the next nodes, right, we make use of the field which is utilized for next. So here we can just see the algorithm. So again, almost it will be the same as the search algorithm. Just instead of just searching and presenting that the search was successful, now you have to print it or display it onto the user screen. So or the output console. So here what we do is we are just giving the name print. So here we are not searching for any element or we are not doing anything. So no parameters are being passed. So we start off the algorithm for printing the elements. So now first condition what we check first is equal to null. So what is this telling? This is checking whether the linked list is empty or not. If it is empty, you go to step 3. So what you specify? You specify that list is empty. That is the linked list is empty and you stop the printing operation. Now if at least there is one element, then this condition will fail. So therefore what you do is you go to step 4. So in step 4 what we do, we look out whether there is only one element or not. So whether first is equal to last checks that whether there is only one element present in the linked list. So if we check at this point over here, so when will be first equal to last? When there is only one element in the linked list. So if you just observe, so first is equal to last when there is only one node present. So if there are multiple nodes, then first is not equal to last. So in the first case, you're checking whether the list is empty. In the next condition, you are checking whether there is only one element in the list or not. So if there is only one element, you need to print only that element and then stop the process of printing, or else you have to keep on traversing till you reach the last element. So here, if this condition is satisfied, then you go to step 5, you display whatever element is present in the info field and you stop the process of printing. Now, if this condition fails, then what it implies, there is more than one element present in the linked list. So if that is the case, you need to go to step 6. So in step 6, what you're doing is you are setting the pointer to point to the first element in the linked list. And what you do is you repeat the process of printing till you reach the last element, till you reach the last element. So here what we are having, we initialize the pointer to the first this thing. And then what we do is we repeat the steps from 8 to 9 till we observe that the pointer becomes equal to the last pointer. That is, till this condition is satisfied, you repeat steps 8 and 9. So what you're doing is you are traversing the elements which are present in node n to n minus 1. So you're traversing from node 1 to n minus 1. So that is what this condition specifies. So n minus 1 nodes are traversed and the info field is being printed onto the say output console. So using the PTR arrow operator and the info field. So now once you are printing the elements, you need to update the pointer at each axis. So what you're doing is you are traversing from first node to the second node using the next field in each of the nodes. So in that case, PTR is equal to PTR next. So that is what you're performing over here. So you're pointing to the next node with the help of this statement over here. So if PTR is not equal to last node, again, these two steps are repeated. Now, by chance, if this condition is not satisfied, then what it indicates, you have reached the nth node. That is the last node in the linked list. So therefore, what you have to do is you have printed the elements which are present from 1 to n minus 1 nodes. Now the last node element also has to be printed. So what you do is you display last element using this instruction, say last, using the arrow operator, you print the element which is present in the info field and then you stop the process. So this is what you can observe in the print operation. So it is also similar to the search operation what you're performing with slight variation. Now, along with this, you can even check out with different logics which are possible. So it is not necessary that these conditions also these conditions only have to be followed. If you have some other simple logic also, you can proceed with those things. So now let us look at a program which is used to implement the linked list and perform few of the operations. So we'll just try to run a C program and try to see what are the things which are moving around. Okay. So here we have the program in which we have looked forward for implementing the linked list and performing few of the operations what we have discussed. So here we we include the libraries which are necessary or the header files which are necessary. So here we are declaring the node in the form of a linked list. So this will be appearing as a linked list. And as we had specified, we have the info field and we have the next field, which is associated with each of the nodes. So now here, what we do is, if you just observe, this is a global parameter. So it is accessible by all the functions which are written in this C program. So this is you are declaring it. You are declaring the structure associated with a single node, which is having two folds, info and the next field. So here you can observe that the info field will store data which is pertaining to the data type of integer. And this pointer, if you just observe, it will point to a data which is of the type struct node. It is of the type struct node. So now in this statement, if you just observe struct node, so what we are doing is initially we are initializing the pointers first and last. So these are the special pointers which the first pointer points to the first element in the linked list, and last pointer is a special pointer which points to the last element in the linked list. But before we start, there are no elements present in the linked list. So therefore, what we do is at the start we initialize these two parameters to null. So here again on observation is, since these, if you just observe the declaration, they are again declared as a global parameters. So the first pointer and the last pointer are global parameters. So now next, what are the operations which we had observed? So we had observed insert, delete, and say the print operations and the search operation. So these are the four operations what we look out for. So here this is just telling you the signature of the function. So again, insert is a function name. What it is returning nothing. Why it is used when you're returning nothing from the function. And what is the parameter it is looking for? It is looking for an integer parameter to be passed. So it will accept an integer parameter. Now here del is a operation which will be, sorry, it is a function which will be utilized to delete an element from the linked list. So in this case, what is the parameter it will accept? It will accept one parameter which is of the type integer, and this function will return a data which is of the type integer. So here again void and void is present. So this indicates that there are no elements which will be passed to the print function, and print will not be returning any values. Hello. Here, madam. Madam, we have a function which is termed as search, which will accept a parameter which is of the type integer. Now here, what it returns is, you can just observe, it is struct node star. So what does this indicate? It indicates that this function search will return a address which will be pointing to the data type of struct node. So this is what it indicates. Okay, if star was not present, then it will just return a value of the type struct node. But since star is there, what happens is this indicates that this search function returns a value which points to struct node type. So this is these are the declarations which are pertaining to the functions. Now next what we have is int main. So in this case, you declare the values which you will be utilizing in the entire process. So now let us just try to see what are the functions you can look out for performing. That is the operations what you will be looking out for. So here while one, so this is actually a infinite loop. So since while true, so it is like while true. So this condition is always true. So it will be in the infinite loop. So in between, if you have to come out of the loop, you have to make some observations as to you can see that you will be going through break statement and other statements. So you can just see using the break statement, I can come out of the loop of while. So now, so we perform this operation in a continuous form. So now what is the thing you do is you ask the user to enter one of the operation. So you ask whether if you enter one, you'll perform insert operation. If you enter 2, you perform delete. If you enter 3, you perform search. If you enter 4, you perform print. And if you enter 5, you exit the process. So here what is happening? You are printing, you are asking the user to enter his choice, whether it is 1 to 5. So that choice will be stored in the variable which is named as choice over here. So based on this choice, you have to call one of these functions. So now that is what we are performing in this switch case statements. So here we can observe. So you are asking if the choice is 1, that is you want to insert the element, then you have to ask the user to enter the element which you want to insert. So for that you call the insert function and you pass this num1 parameter. So which is the element that has to be inserted. So if that is successful, you print that you have inserted the element successfully. So that is what you perform in this case. Okay. So if the choice is 2, so if the choice is 2, you delete, you perform the delete operation. So therefore what you do is you call. So here we have, you ask the user the
Sir, excuse me.
number you want. 1 second.
So it's me.
Hi. Okay, I'll continue. So in case 2, what we are doing is we are performing the delete operation. So we ask the user to enter which element you want to delete. So and then we call the delete operation. So and we return since delete returns an integer, we need to use num2 is equal to del num1. So you're passing the parameter num1, which is the element that has to be deleted. And after the delete operation, you'll be returning a parameter which is of the integer type. So let us see what it is in the delete function itself. So based on the number what you are receiving, you are printing that element is present or whether the element was deleted successfully or not. So based on that, you are performing this operation. So if del function returns minus 9999, so it gives an indication that the element is not present in the linked list. So therefore, you will not be able to perform the delete operation, or else you have performed the delete operation in a successful way. So that is what you will be checking out in num2. So again, if this is executed and you come across the break statement, what does break statement do is break statement helps you to come out of the loop, immediate loop what is present. So in this case, actually it comes out of the switch statement. So when it comes out again, it keeps on traversing. So let us see the next part. So in case 3, in case 3, what we have is case 3 is utilized to search an element. So in this case, you have to ask the user to enter the element what you want to search. So that element is stored in num1. Now in search operation, we saw that what it returns. So here we can see that it returns a address which is of the type struct node. That is which points to the data of type struct node. So here you can see that location is a pointer which points to data of the type struct node. So therefore you have to define this pointer whose name is given as location. So if the search is successful, you are returning the location. So in case 3, that is what you look out for. So location you return, search operation returns a location which is pointing to struct node. So therefore you store that information in location. Now if we observe what we have is if location is equal to null. So if location is null, then it gives an indication that the element is not present in the list. So this is how I try to identify that whether the element is present or not. Now, if location is not equal to null, then what we have to do is we have to check out whether the search was successful or not. That is, we try to see which element was, whether the element is which at which location it is. So that is what we have to look out for. So here we have, in else part, if you just look out, so if location is not equal to null, that is you have identified the location of the element. And what you're doing is if location is equal to last, that is, it is the last element what you're pointing at. So you're just printing that element %d is the last element in the list. That is just you are specifying that this is the last element. So that is the num1 what you are trying to search out for. But if it is not the last element, then it is present at some other location. So what you're doing is you are just trying to specify that element %d, that is num1 is present before element %d. So it is just giving an indication that the element is present at what point. So that is what they are trying to specify in the statement. OK, so it is present before which element? That is what they are trying to put forth here. So it will be present before location next info field. So because of which they are cross checking whether it is the last element or not. Or else if you want, you can just directly print the element and the location information. So even that is also fine. In this case, they are using that logic. So what you're performing. So in last one, you look out for printing. You look out for printing of the elements. So that is case 4. In this case, what is happening? You just call the print function and it traverses and prints all the values which are present in the linked list. So last one, you exit from the loop. So once this is done, you come out of the break statement. That is, it comes out of the loop which is immediately associated with this. And last one, if you don't enter 1, 2, 3, 4, 5, then you have to print that the choice is incorrect. So that is what you are doing over here. So this process will be continuing in this form. So let us look at the functions, what they have specified. So here we can look that we have a insert function. So which is returning nothing, but it is taking a parameter of the type or the variable of the type integer. So from num1, what we had declared above, so that will be present over here. So that is the element which you have to insert. So now before proceeding, you create a new node associated with this. So in which PTR will be utilized to store the value. So this is the address what will be utilized to store this value. So this is the statement what you observe here is actually a dynamic memory allocation. It's a dynamic memory allocation what we observe. So here we have PTR, which is of the type that is, it is a pointer which holds the address of the variable of type struct node. So in this case, what we do is we make use of malloc function and allocate that location to PTR. Memory is allocated to PTR. So here struct node. Now since integer and other stuffs you generally don't use with size of operator, but struct node what happens is this is a user defined operator. So therefore you have to look out for using the size of operator. So what you're doing is you are checking what is the size of the struct node. But in integer and all, what is there? It is fixed. But if in structure, if I look forward, right, if I just observe here, suppose this is holding 2 bytes and the address is holding 4 bytes. So total 6 bytes. Total 6 bytes. Suppose if I add another field over here, what happens is it consumes, say, integer is added, another 2 bytes is increased. So each structure will not be having the same size. So therefore, we need to look forward for these aspects. But if I declare an integer, right? So num1 will hold 2 bytes, num2 will be 2 bytes, choice will be 2 bytes. So there will be no change in the size of these. But there will be change in the size of the structures what we are declaring, because we don't know how many elements are present. So and what is the size which is observed over there. So therefore what you have to do is you have to specify the size of the node what you are utilizing. So based on that size, the allocation will be done with the pointer. Okay. So it is because of that purpose you are using the size of operator over here. And this is nothing but the typecasting. You are converting whatever address you are getting to to the type struct node. So this is what is being done over here. So this is the typecasting what you are looking forward. So you get the address. So that address you tell that it has to be of the type struct node. So you have to make it of the type struct node and then you store that address in PTR. So that PTR will be now the location where the value will be stored. So since PTR is of the type node over here, that is a struct node, so it will be having two fields. One is info field and one is the next field. So in PTR info field, I have to store the value. I have to store the value. So using this statement, I store the information. Now, what we do is we check out whether the list was empty or not. So that is if list is empty, if first is equal to null. So it indicates that this value what we are inserting is the first element. It is the first element. So therefore what we do is we check this case, and what we do is if this is the first element, then what I do is I initialize the pointers. That is PTR is initialized to first special pointer and PTR is initialized to last special pointer. So these are the two things what we look out for. And what we do is, since the list was empty prior to insertion, in the info field, I have stored that information and I got to know that presently the list is empty. So this is the first element which I'm adding to the list. So what I do is I have to update the first and the last pointer information to the pointer which is pointed for the value. So that is what I'm performing here. And in the in the next field of the present value, that is next field which is associated with this node, I have to store it with the null. I have to store it with the null. So that is here, sorry, here we can observe it. So here what is happening? So you are entering the node. This is the first node. So previously it was empty. So what you did, first is equal to last, you mapped it to the address of the first node. And since this is the only element which is present now, so you have to point this value to null. So that is what you are performing in this case. So this is what you are doing in this part. Now suppose if first is not equal to null, then it indicates that at least one element is present. So what you have to do is you have to insert the element at the end of the list. So how do you access the end of the list? Using the last pointer. So last pointer next field, you initialize it with PTR. So here you can observe that if you have this node and after this you want to insert. So what is present in the next field of the last node? Null is present. So now what you're doing is you are overwriting it with the address value of the new value, address parameter of the new value or the element what you are inserting. So that is what you are performing over here. And what you're doing is once you associate that one, you have to store null in the next pointer of this new value. Since this new value or the element what you're inserting becomes the last element of the linked list. And with that, you also initialize the last pointer to point to this new element. since it is the last element what is being inserted in the linked list. So this is the operation which is pertaining to the insert operation. So this is all for today. In coming forth session, we'll discuss regarding the next operations, and then we'll look forward for execution of the same program. So let us meet in the next session. Thank you. So anything